Hi everyone. In a previous slide, we were learning about how to name binary compounds for ionic compounds, and we were also learning how to recognize if the first element has more than one valence option, how to go about naming those type of ionic compounds as well. Today we're going to go through how to name polyatomic compounds, and poly means many. And so in this case, we're looking at ionic compounds that have more than two atoms involved in their structure. Before we move ahead, I want to just show you there are a couple of really important resources that will help you in completing this lesson and upcoming worksheets. You're going to need to go to the content section of our class, and under student resources you're going to find there's a periodic table and polyatomic ions sheet. So when you click on those, okay, this is what you end up getting, and then you can make those into bigger tabs like I've done so that you can see them a little bit more clearly. Okay, so these are going to be useful to us moving forward. Okay, so let's get started with the polyatomic ions. So you already have this lesson sheet. And again, if you don't have this lesson sheet, that's okay. You can just write this out in that 3-ring notebook that you have, or perhaps on a separate sheet of paper where you were writing down and learning about how to name other ionic compounds. So the first thing that we want to do is we want to take a look at the fact that they want iron and phosphate. Now I noticed that anything that ends in ate or ite, that should be a little bit of a clue to you that it's going to be more than two atoms linked together. So it's going to be a polyatomic. So ate or ite. This case, iron. Iron has more than one valence option. And I know that because on my periodic table, we can see iron here has a valence of 3 or 2. And the charges indicate that on the periodic table. When I look at phosphate, this is where I go and I take a look at my polyatomic worksheet here. Here's a whole bunch of different ions. Phosphate is right here. And phosphate is PO4 with a charge of -3. So what do I do now? What you're going to do is we're going to put phosphate, any of our polyatomic ions, we always put in brackets to start with, and I put the respective charges. So I know that this is a -3, and iron can be either a +2 or a +3. So I will choose two different options, option 1 and option 2 for iron. We do the same thing that we would do normally. We have to do our crisscross, but the polyatomic ion must go in brackets. What we do is we bring this to outside the bracket. And remember that the first atom is always the positive ion, and then the polyatomic here happens to be the negative ion. So what we end up doing is we get Fe bracket, oops, we want to put a 3 there, bracket PO4 bracket 2. And when we go to name this, we have to look at the valence that was used in this scenario before the crisscross happened. So this is going to be called iron 2, and we put the Roman numerals in brackets, phosphate. Now, if you did not put the brackets around that phosphate and you just put a 2 there, it wouldn't be correct. Okay? Now, the next thing, we're going to do this potential compound that can be made. We get Fe3 bracket PO4 bracket 3. Now, because the number outside the bracket and this number here, 3, beside the iron, they both have a common factor, you must reduce those. And remember that whenever there is a 1 outside of the bracket, you can drop the brackets. So in this case, FePO4. Now, when you go to name these, you have to be really careful. It would appear as if there was a 1 because we've reduced our subscripts there, but you have to go back to before the crisscrossing happened, what charge did you pick for iron? And in this case, you picked a 3. So this compound is iron 3. And you might think, well, why not just call it iron phosphate? You can't do that because iron 2 phosphate and iron 3 phosphate are two very different compounds with different properties and different uses. So we must use this international naming system so that everybody across the world is on the same page and we know what chemicals we're talking about. Let's go ahead and do calcium hydroxide. So again, I'm going to look up the valence for calcium. Here's calcium here. Calcium has a charge of +2. What is hydroxide? Hydroxide is one of those polyatomic that we're not necessarily familiar with. So here's hydroxide right here. Different than hydride. Hydroxide is OH and it has a charge of -1. Whenever it just says a negative and there's no number beside it, you assume that it's a -1. Okay, so now what we're going to do is we're going to do this example. Here's calcium. It has a charge of +2. It's the positive ion. Hydroxide is one of my polyatomic, so I must put it in brackets. It's a -1. You do your crisscross. The 2 comes outside the bracket. The 1 you leave out because you assume that the 1 is there, okay? If you did this, CaOH2, that would be incorrect because when you go to count the number of atoms for this particular compound, this 2 tells you you have 2 atoms of hydrogen, you have 2 atoms of oxygen. Over here, you have 2 atoms of hydrogen and 1 atom of oxygen. So it's imperative that you leave the brackets on. We call this calcium hydroxide. We do not need to put a Roman numeral because calcium does not have more than one valence option. So those are 2 examples of how to do polyatomic compounds for ionic compounds. And there are a couple of more in the next slide. So practice makes perfect. What I'd like you to do is make sure you do the practice worksheets and follow up with any questions that you might have with a quick email to me, and we will get that sorted out if you need.